To 4.08, we're going to solve radical equations in context. So to start us off, we want to make sure that we are pushing ourselves forward as far as solving radical equations. What I want you to do is go ahead and return to the problems that you were working on at the end of the week. And our goal is going to be to get to this Hall of Fame area. So wherever you were, if you finished all of these and you then all you need to do is check your answers, which I'll provide in a second. If not, you're working from wherever you started off, and you're going back. Remind yourself the different keys to solving radical equations. Go ahead and give it a try, and I'll talk about them briefly before we move on. Okay, so for this first one here, all I need to do is square both sides right off the bat. Make sure that you're squaring everything on the left side. So this will be 4x squared. And on the right side, you'll have 4x minus 1. And then you're going to use this quadratic. So you're going to subtract 4x and add 1 on both sides. And when you do that, you're going to be left with 4x squared minus 4x plus 1 equals 0. And you can use the quadratic formula to solve that. And you will get that x is equal to 1/2. Now, when you use the quadratic formula to solve this, you're going to notice that you're going to get two answers. Okay, so I want to make sure that you try this. You should try this right now if you haven't already. You're going to get two values, and you need to be able to determine which one will work. For this one over here, same idea. You can start off by squaring both sides. Don't forget that you've got to, when you square this here, you have to FOIL this. So this is the same as this is saying 3 plus the square root of x times 3 plus the square root of x. And when you do that, you need to FOIL this out. And so go ahead and do that. And when you do, and then you solve, and you'll square this side as well, of course, you're going to find that there are no solutions. Okay. All right, moving on. Here is a little Pythagorean theorem reminder. So if I want to write an equation for y in terms of x, so y here is the hypotenuse. So I know that y squared is going to be equal to x squared plus the other side squared, which is 64, 8 squared. And now I want y in terms of x, so I square root both sides, and I'll get y is equal to the square root of x squared plus 64. And notice here that I have to square root both sides, and in doing so I will get y is equal to the square root of x squared plus 64. Now you might be wondering, why is this not plus or minus? Well, this is a side length here. Y is a side length, so it can only be a positive value, so I just assume that it's positive. And then if I want to solve this equation for x, and I realize that there's a y in this equation, and I just have to substitute what y is equal to. So I pull this out here, and I'm going to end up with the square root of x squared plus 64 minus 8 is equal to 9. And I can solve that, and when you do, you should notice that you are going to get values for x and y that will make this a perfect right triangle, as it is supposed to be, and I should include the right triangle sign there. Okay? Alright, I hope those went well. If you still have questions, go ahead and make sure you write them down so we can talk about them, but now we're going to move on to a contextualized situation. Alright, so this is a similar question to one that you've seen before, but it is important to make sure that we are able to understand what these radical equations are used for and how to interpret the results. So pause the video now, go ahead and copy this down and answer both A and B to the best of your ability, and I will talk briefly about it in a few seconds. Right, so I'm not going to talk about the setup because we should be able to understand that fairly well by now. For part A, we're given the length L of the pendulum, and we're asked to find the period T. So in this situation, I'm just going to plug in my value for L and solve for T. For b, however, I'm given the period, t, and I'm asked to find the length, L. So the setup for this, I will know the period, 3.37, and what I do not know is the length. So I'm going to try and solve for the length. Now, once we've set it up like this, we know how to find L here. We've done that. If I just go back and think about how I solved expressions with radical equations. This is the fraction pi over 5, so we can easily get rid of this on both sides by multiplying by its reciprocal, 5 over pi on both sides. And so now I'll be left with the square root of 2 times L, and on the right side, whatever this value is. Okay? And now from here, you should be able to take it all the way. So go ahead and finish solving it out if you did not. Make sure that you write down a question or answer someone else's question in the comments below, and I will see you guys on Monday.